Let's take a look at the exercises for chapter 3. Multiple choice questions. The mean of a sample is computed by summing all the data values and dividing the sum by the number of items. The notation X bar usually refers to the sample mean. Which of the following is not a measure of central location? This would be variance. Another term for average is mean. Mean average is expected value. Also, it's another term for average. The Greek value, the Greek letter mu usually refers to the population mean. We use Greek letters for population parameters. The middle value in an order array of numbers is the median. The median, C. Which of the following is a measure of dispersion? A measure of dispersion, that would be the variance. The difference between the largest and the smallest data value is the range. The standard deviation of a sample of 100 observations equals 36. The variance of the sample equals 2. Therefore, so the standard deviation of a sample of 100 observations equals to 36. In order to find the variance, we have to square the standard deviation. So 36 squared, that would make 1,296 for the variance. The heights of 25 individuals were recorded and the following statistics were calculated. The coefficient of variation will be, the coefficient of variation is S over X bar times 100%. I have the mean, I have the variance. In order to find S, I take the square root of the variance, square root of 900. This will be equal to 30. So 30 over 60 times 100%. Your coefficient of variation will be 50%. The first quartile is the same as the 25th percentile. The interquartile range is the difference between Q3 and Q1. The interquartile range is used to overcome what difficulty of the range? The range is influenced too much, as we said, by extreme values. The number of standard deviations that the value X is above or below the mean is the z-score. That's the definition of the z-score. The empirical rule says that approximately what percentage of the values would be within 2 standard deviations from the mean in a bell-shaped set of data. 2 standard deviations, that would make it 95. The variance of a sample of 81 observations equals to 49. The standard deviation of the sample, therefore, will be equal to what? I have S squared equals to 49. I'm looking for S. It's always the square root of the variance. Therefore, the correct answer will be 7. Let's look at the exercises. With the first exercise, we have the SAT scores of 10 students. That means that N is equal to 10. We want to calculate the mean, X bar. We add all the entries. We divide by the number of entries that we have. This will be 1100. Calculate the median of the sample. First step, we place the data in order. 890, 940, 940, 1020, 1060, 1120, 1150, and 1,350, the last entry. So we have 10 entries. That means we have to take the average of the two middle values. So the median will be equal to 1,060 plus 1,120 divided by 2. So this would be 1,090 for the median. The mode, once you place the data in order, it's a lot easier to determine whether you have a mode, and if so, what the mode is. We notice that 940 is the only entry that occurs twice, higher than any other. Therefore, the mode is 940. For the second example, the mean, we have 9 entries, so n is equal to 9. We add them all and divide by 9. X bar will be equal to 2. To find the median, we place the data in order: 0, 1, 1, 1, 2, 2, 3, 3, and 5. Therefore, the median will be the value in the middle, which is 2. Mode is the entry with the highest frequency. In this case, the highest frequency is 1. Now, a private research organization studying families in various countries reported the following data for the amount of time 4-year-old children spend alone with their fathers. So we have n equal to, n is equal to 5. We want to find the sample variance. The sample variance S squared is equal to the sum of the square entries minus the sum of all the entries squared over the sample size, and all of this over n minus 1. So the first thing we do is we find the sum of all the entries: 60 plus 45 plus 55 plus 50 plus 40. The sum of all the entries is 250. And then we take the sum of all the squared entries, which means 60 square plus 45 square plus 55 square plus 50 square plus 40 square. And this will be equal to 12,750. We go back to our formula and we plug in the information. Sum of the squared entries, 12,750 minus the sum of all the entries, 250 squared, over n, which is 5, and all of this over 4. N minus 1, 5 minus 1, 4. So this will be equal to 62.5 for the variance. Calculate the sample standard deviation. Calculate the sample standard deviation. All I need to do, S is equal to the square root of the variance, square root of 62.5. This would be 7.906. Coefficient of variation. Coefficient of variation is equal to S over X bar times 100%. So that means 7.906 divided by 50. X bar. X bar is 250 over 5, which is 50, the average, times 100%. This will be 15.81%. A researcher has collected the following sample data. Find the variance, standard deviation, and coefficient of variation. Once again, with same process, different example. To find the sample variance, I have the formula is, once again, we write down the formula, sum of the squared entries minus the sum of the entries squared over n, and all of that over n minus 1. The sum of all the entries is equal to 64, and the sum of the squared entries is equal to 532. So you plug in the information in your formula. 532 32 minus 64 squared over n is equal to 8, and all of that over 7. 2.856. Sample standard deviation, S, is equal to the square root of the variance, square root of 2.856, and this is going to be equal to 1.69. Coefficient of variation, once again, S over X bar times 100%. S is 1.69. X bar will be 64 over 8 times 100%, and this will be equal to 21.13%. Now, the hourly wages of 10 individuals is given below. You have all your entries. We first place the data in order. So we will have 10, 12, 14, 16, 17, 19, 20, 22, 25, and 27. Always, whenever you're looking for percentiles, you want to make sure that your data is always in order. I'm looking for the 60th percentile. I is equal to P over 100 times N. N is equal to 10. So 60th percentile, P is equal to 60 over 100 times 10. This is going to be equal to 6. Which means I take the average of 6th and 7th ranked observation. 6th and 7th ranked observation, this will be 19 plus 20 divided by 2, 19.5 for the 60th percentile. P80, I will be equal to 80 over 100 times 10. This is 8, which means the average of the 8th and 9th ranked observation. 8th, 9th ranked observation, this will be 22 plus 25 divided by 2. This would be 23.5 for the 80th percentile. Q1. Q1 is equal to P25. I will be equal to 25 over 100 times 10. 2.5, I round up to 3. I take the third ranked observation. The third ranked observation will be 14. Q2, P50, I will be equal to 5. I take the average of 5th and 6th ranked observation. 17 plus 19 divided by 2, 18. Q3, P75, I will be equal to 7.5, which I round up to 8, and I take the 8th ranked observation, which is 22. IQR is equal to Q3 minus Q1, 22 minus 14, IQR will be equal to 8. Now, for the next problem, the mean life of a particular brand of light bulb is 1,000 hours. So let's say X bar is equal to 1,000, standard deviation is 50. Tests show that the life of the bulb is approximately normally distributed. It can be concluded that approximately 68% of the light bulbs will last between which two values? Empirical rule, 68%. 68% of the data, normal distribution, X bar plus minus 1 standard deviation, 1,000 plus minus 50. So 68% of the data will be between 950 to 1050. Jessica Salas is reviewing the warranty policy for her company's new model of automobile batteries. Life tests performed on a sample of 100 batteries indicated an average of 75, standard deviation of 5 months, and that battery life is approximately normally distributed. Approximately 95% of the batteries will last between which two values? So 95% means X bar plus minus 2 times your standard deviation. 75 plus minus 2 times your standard deviation, which is 5. So 75 plus minus 10. So you 95% of the batteries will last between 65 to 85 months. Consider the following population of numbers. We have 40, 60, 70, 100, 110, and 190. I want to find the z-score for 70. So for x equal to 70, calculate the mean and the standard deviation. Now, in order to find the z-score, we first need to calculate the standard deviation. And to calculate the standard deviation, I will just use the numbers based on what we have. We will take the square root of 68,300, which is the summation of the squared entries, minus 570 squared, which is 570 is the summation of the entries, over the sample size, and all of this over n minus 1. Once again, we need to take the square root. And if we do this, this will be 53.198. To find the average, we add them all and divide. So you would do 40 plus 60 plus 190 over 6. So this would be 95. And to find the z-score is x minus x bar over s. X is 70 minus 95 over 53.198. So your z-score for 70 would be negative 0.47. That would indicate that 70 is 0.47 standard deviations below the mean. Below the mean. Now, the weights in pounds of 50 individuals were recorded, and the following statistics were calculated. We have the mean, the range, the mode, and the variance. I want to calculate the coefficient of variation. The coefficient of variation is equal to S over X bar times 100%. I have the mean. I don't have the standard deviation. However, I am given the variance. From the variance, I can find S by taking the square root of the variance, square root of 900, which is equal to 30. So this will be 30 over 165 times 100%. So this will make a coefficient of variation of 18.18%. And this concludes the exercises for chapter 3.